This video provides a quick walkthrough of our joint distributions module. This module provides a review of how the mean and standard deviation of a given random variable relate to the shape of the distribution of that variable. And it also introduces the concept of a joint distribution and demonstrates how the correlation and covariance describe the co-movement of two random variables. We can start by looking at the two random variables in question, the height of parents and the height of children. And we can start by just inputting a height and standard deviation in each case. So let's just assume 69 inches on average for parent height and standard deviation of 4. And we'll set the same for kids. And when we click generate, we see we get two, and for now I'm just going to leave correlation alone. And we see we've got two histograms, and because I've set the mean and standard deviation the same in both cases, these two histograms look relatively similar in the randomly generated data. With a mean here at 69 and a standard deviation of 4. But let's assume now that perhaps the older generation parents are of lower stature and greater standard deviation, and kids, the next generation, are taller and have a shorter, smaller standard deviation, for example. And now we regenerate the data, and what we see is that the distribution of parent height has shifted to the left relative to children, and that the dispersion or distribution spread of the heights for the parent random variable is wider than for children, because we've set the standard deviation smaller for child height than for parent height. Now we can come over and look at what's happening with the joint distribution. Here we've got a scatter plot that plots parent height is here on the x-axis and child height on the y-axis. And since we have a covariance of 0, and we've set this so that users can set the correlation and be told based on the standard deviations what the corresponding covariance is. In this case, we've got 0, so we see no real directional relationship between parent and child height. But let's assume there's a positive correlation of 0.6, and we see that the corresponding covariance is 7.2 inches. So let's regenerate. And what we now see is that there is a positive slope if we were to estimate a slope of a line through this data, sort of starting to introduce the concept of regression. And we can increase the correlation further. Let's try a positive correlation of 0.9 and regenerate. And what we see is as the correlation increased, the relationship became tighter and steeper. But again, the variation in child height here is relatively narrow compared to the spread of parent height. Right? And again, you can see by playing around with, if we were to increase the standard deviation of child height and regenerate, we'll see that we get a wider spread in child height, but that positive relationship holds. Now, one other feature here is when we highlight a point in the scatter plot, on the left, the green and red dots in the child and parent height histograms show us the corresponding point. So a positive correlation in this particular case is an instance where relatively tall children are associated with relatively tall parents, and vice versa. When I come down here to low parent heights, I see that shorter parents are associated with shorter children. Now, what if we were to, instead of a positive correlation, assume a negative correlation? Again, I haven't now just changed the mean and standard deviation of either of the random variables, but I now regenerate. And what I see in this case is that with a negative correlation, relatively tall children are associated with relatively short parents, as I can see in the corresponding red and green dots to the left. And relatively tall parents are associated with relatively short children. Again, once we've put in these parameters, students can play around with all the different features and see how they affect both the spread and placement of the distribution of each random variable, and see how that relates to the covariance.